Hello class. So this is the review of the revised review sheet, or solutions to the revised review sheet. All right, let us look into this one together. So here we have RS is equal to 30. And then XD is equal to 44. We are looking for the bottom line right here. As we already have talked about in class, the middle line, because it was connected by the midpoint, right here. Now, therefore, the 44 should be the average of these two lines. Now, that means we're going to have 30 plus x over 2. Taking the average must be equal to 44. Now, then of course we can always have this one as over 1 and then cross multiply them if you wanted to. Then we end up getting 30 plus x equals 88. Now, by subtracting 30 from both sides, we'll end up getting x equals 58. Alright, great. Let's move on to the next question. Now, here we have tangent and then secant. The relationship here is that tangent squared, when you multiply this one twice by itself, that's equal to outer line segment times the whole thing. Now, then the values are, here we see PB is equal to 4, and then BC, this portion is equal to 5. And of course we don't know the PA, which we call it as x. So here we go, x squared is equal to 4 times the whole thing, which is 4 plus 5. Then that's equal to 4 times 9, where 4 plus 5 becomes 9. And therefore, it should be equal to 36. Then, where x squared here is equal to 36, then x now becomes 6. And I believe there might have been choice 4 right here. Alright, let us move on. Now in this question, here we have parallelogram. That means one of the property that we realize is the opposite sides are congruent. Then it says SV is equal to x plus 3. So this is equal to x plus 3. That means whatever comes out on the other side must be also equal to each other. And then VU is equal to 2x minus 1 right here. And then TU right here, which is 4x minus 3. Now, then more than anything, we get to realize that this must be equal to this one. Now, using that, we can set up the equation. X plus 3 must be equal to 4x minus 3. Now, by adding 3 on each side, we would have gotten x plus 6 must be equal to 4x. Now, by subtracting x from each side, we would have gotten 6 equals 3x. Now, to have the x by itself, we gotta divide by 3, right? Then x would have been equal to 2. Since x is equal to 2, then this line segment becomes 2 plus 3, which is equal to 5. And that's what SV would have been. So there it goes, our answer is choice 1. Alright, the next question. Here we have two chords meeting inside of the circle. Now, how do we find CEA? Which means this portion of the angle. The way which we have to do it is simply adding those two and divide by 2, then we end up getting 87 plus 35. Divide by 2. Now then here we have 87 plus 35 becomes 122 divided by 2, which is 61. Now, as you know, if these two lines was made up outside of the circle, then we would have subtracted those two angles. But since they're meeting up inside, we will end up adding and then dividing by 2. All right, now next. Here we have two lines are parallel, EB and then BC. And then that means we realize this angle is congruent to this angle. And then this angle is reflexive to both triangles. So we know that this triangle AEB is similar to ABC. Now that's the concept behind this. And AE is equal to 3, while ED is equal to 6. Both of them are notice that 6 units here is not a whole triangle, but part of the triangle. And then DC here is equal to 15. And we'd like to find out EB, which is this one. So now, if you have to set up the ratio, the small, this is the side, 3 to the whole thing, which is a big triangle. Now we know that to be 9. That ratio must be the same for the right side of the triangle, question mark, the whole thing. So here we have 3 to 9 must be equal to question mark to 15. Once again, you can realize that this is simply 3 times of the previous one. We can just use that concept or cross multiply them once again. Then we have 9 question mark is equal to 45. So here we have dividing each side by 9, we get to realize question mark would have been equal to 5. There it goes. That's our answer for this one. Now, the next question. Now, notice EB and AB and then CD are parallel. That means 2 parts of the intersected arc right here. AD and BC would have been equal to each other. That's one thing that we get to realize right away. Now, and we are looking for CDB, CDB, then this angle becomes simply, since it's an inscribed angle, this will be the half of 60, which gives us half of 60, which is equal to 30, would have been our answer, which is choice 2. Now the next. Here, this is one of the more interesting questions. We have to set up the relationships. Now, some of us might have used the Hills and Sass and many other relationships. But now, when you look into this one, we realize that this triangle is similar to the big triangle. Now, using that, because we realize both of them, a red triangle has one right angle, the blue triangle also has one right angle, and this angle here, dotted angle, is common in both triangles. So therefore, by AA, we know that those two triangles are similar. Now, knowing that this side is equal to 6, this side is equal to 8, we get to figure out the hypotenuse right away. Having 6 squared plus 8 squared is equal to hypotenuse h squared. And here we have 36 plus 64 is equal to h squared. And h squared now becomes 100. And by taking the square root on both sides, h will be equal to 10. That's what we end up in here. Now, then by setting up the proportion, um, here we have 6 is the opposite of the right angle from the red triangle. So 6. Now, same thing on the blue triangle would have been opposite of the right angle, would have been 10, which we just found. So both of them are opposite of the right angles. Now, the next one is this x, which we are looking for. X is opposite of unmarked angles from the red triangle. You see, this is dotted, this is right, but there's no mark here. That was x. But corresponding side from the big blue triangle would have been unmarked. This is dotted, this is a right angle. Right here, this is unmarked angle. Opposite of that would have been 6. There we have it. And as you once again cross multiply, we end up getting 36 is equal to 10x. By dividing it by 10 on each side, we get to realize x equals 3.6, which is this one. Alright, let us move on. Here we have once again tangent and then secant. Here then we're going to have tangent square is equal to outer times the whole thing, whole secant. Now, then how are we going to calculate this one? Let us say, since we are looking for CD, let's call this one as x. Then we realize 8 squared, that's the tangent. Outer, which is 4. The whole thing is 4 plus x. Then we have 64 is equal to 4 times 4, 16, plus 4x. Now, as you subtract 16 from each side, we have 48, which is equal to 4x. Then divide by 4 on each side, we now realize x then is equal to 12, which is right over here. Now, here we have, how do we show that these two triangles are similar? That is the question here. Now, one thing is, this angle will be equal to this angle, vertical angles. Now, second one is angle CAB. CAB, which means that angle, is congruent to CED, which is this angle. That means we realize the two pairs of the angles are congruent. And by AA, we know that those two triangles are similar. Now next. In similar triangles, we realize the angles are congruent, while sides are in proportion. So here we have angles, so therefore they have to be equal to each other. So 4x plus 30 must be equal to 5x plus 10. Now then we have, when we subtract 10 from each side, then we realize 4x plus 20 is equal to 5x. Now as you subtract 4x from each side to bring all the x's on one side, we get to realize 20 is equal to x. And there it goes. That was our question, and that is our answer. Alright, the next question here. In fact, we see in one way, two pairs of tangent lines segment. So you see TA, in fact, would have been equal to TE, because point outside of the circle to a circle. two tangent lines are always equal in length. Now, likewise, from TC must be also equal to TS. Whole thing is equal to this whole thing, which makes us to say that these two left over, meaning AC and then ES, those line segments will be also equal to each other by subtraction partially. Now, what the question says here, we have TA to AC is 1 to 3. That means this is what? 1x, and this can be 3x. While TS, whole thing here is equal to 24. Now, if this is 24, then we realize this is also equal to 24. Now, then the equation which we can set up is x plus 3x is equal to 24. Then here we have 4x is equal to 24, and x equals 6. Now, since we are looking for SE, here becomes 3 times of 6. Therefore, we get 18. That is our answer for this question. Alright, let us move on to the next. Once again, as soon as we realize that those are parallel, that means we know that AC must be equal to BD. And then, so as EC is equal to DF. Now, then which statement must be true? Well, I think we just answered it. Right here, AE and then DF. Now, diagonals of the quadrilateral do not bisect each other. Now, the concept is in a parallelogram, one of the property is diagonals bisect each other. That means this is a parallelogram, so this doesn't fall into the answer. So it's the rhombus, so it's a square, because these are the special parallelograms. But trapezoid would have been our answer because it's not a parallelogram and they don't bisect. Diagonals doesn't bisect each other. Now, in an isosceles trapezoid, AD is congruent to CD. Now, then if you have to draw a diagram based upon that, it would be something like this, where we have AD is congruent to CD, so why don't I call this one as A, B, CD. Now, these are congruent to each other, and BC is equal to 20, and AD is equal to 36. Now, AB is equal to 17. Find the length of the altitude of the trapezoid. So they're talking about this length. Now, the way which we can get this one is through this way. Altitude. Now, when you draw these two vertical lines from, or perpendicular lines from this one base, then we get to realize that this must be also 20. And out of 36, if this portion is 20, then the other two leftover portions must equal to 16. 16 divided by 2, then we get 8 here. Then we can simply use the Pythagorean theorem. So here we have 8 squared plus h squared must be equal to 17 squared. 8 squared, yes, it becomes 64. Plus h squared, which we do not know, it's 17 squared becomes 289. Now by subtracting 64 from each side, h squared becomes now 225. Then as you take the square root from both sides, h gotta be equal to 15. Yes, of course, in this case, negative 15 has been rejected. Then our answer is 15 right here. Now, we have done a question that is very similar to this one before. Now, in order for us to get the answer here, A, B, C, all we have to do is add up and divide by 2. 36 plus 20 over 2. That's equal to 56 divided by 2, which is equal to 28. Yeah, there it goes. Question number 3. Now, here we have AE is equal to 4, and then AB is equal to 12, the whole thing, and BD is equal to 6, which allows us to have the outer side is equal to 6, because outer side is very important. Now, the way the relationship is set up is that outer times the whole thing is equal to outer times the whole thing. Then we can set it with outer, with the upper one, 6 times 12, the whole thing is equal to 4 times, and if you pull this line segment, the diameter as x, then we get 4 plus x once again. Here we have 72 is equal to 16 plus 4x. Now, by subtracting 16, we are left with 4x on the right side. On the left side, we will have 56. And as we divide by 4 on each side, we'll realize that x then is equal to 14. But 14 is the whole diameter. We are looking for OC, which is the radius. And half of that becomes our answer. Now next. Which relationship must be true? Now, when these chords are meeting up together, creating a few different triangles, one thing that we get to realize is this. Angle C right here, ACB, must be equal to angle ADB. Why? Because both of them are inscribed angles to a same arc, which makes these two must be the half of the same arc, makes them equal to each other. So as the other angles right here, angle A and angle B, they gotta be equal to each other too, because they are opposite of the same arc. But wait a minute, that means these two triangles. Triangle ACE, upper triangle, is similar to BDE by AA. Then, wait a minute, AEC and then BED, yes, they are similar. That's one thing that we get to realize right away. Next. Here we have DE is equal to 7, right here, that's equal to 7. AB, the whole thing, is equal to 10. Now, and then BC is equal to 13. Now, but the mid-segment basically means these are equal to each other, these are equal to each other. Where the smaller triangle will become half in length of the big triangle. That's the idea behind it. So if this is 7, then this must be 14. By the same ratio, if this one was to be 5 to 10 or 6.5 to 13, because these are the halves of the whole thing. So therefore, this must be also half of the bottom. Now then, find the perimeter of the triangle ABC. Then we have simply 10 plus 13 plus 14. Then we get to realize the answer is 37. All right, the next question. though these two are parallel lines, and then 10 inches are apart. So therefore, if we notice from here to here is 10 inches apart. Sketch the locus of all points that are equidistant between these two. Equidistance, that means we are looking for line in the middle where the distance will be about 5 and 5 away from each side. And then 7 inches from R. So in fact, we realize that this must be about 5 inches away and 7 inches from point R. That means we'll end up having a circle. And this would have been radius 5 because they're touching just now, but 7 therefore it's going to be bigger than that. That makes 2 points to be our point that satisfies both conditions. Or I should mark it X, I guess. Alright, there it goes. And that's it. So I hope you guys have good time on the exam, and see you later.